The future of advanced manufacturing is here. Hi, I'm Melanie Lang, CEO and co-founder at FormAlloy, where we design and manufacture the most capable directed energy deposition systems. We serve a wide range of customers from aerospace and defense to energy and consumer goods, and work with a wide range of materials from common materials to very unique and advanced. We are able to manufacture and repair castings and forgings, and do more advanced manufacturing techniques such as multi-material and functionally graded materials to enhance component performance.
Hello, I'm Jeff Riemann, the CTO of FormAlloy. Behind me is the X2 Directed Energy Deposition. The X2 is the smallest of our machine models, which also includes our X5 and X5R. All of our Directed Energy Deposition machines are designed and manufactured in San Diego, California. Directed Energy Deposition enables additive manufacturing, surface enhancement, repair, and laser welding of components. The X2 uses an industrial high-powered laser to melt metal powder or wire feedstock for additive manufacturing, surface coating, repair, and joining applications. It's used by space companies, industrial manufacturers, defense contractors, and advanced materials companies.
Our machines work with both powder and wire feedstock for the greatest flexibility. With our enhanced data collection and in situ monitoring and control, we can get end-use parts into the hands of the users more quickly. In addition to providing the most capable DED systems on the market, FormAlloy provides a suite of software to help users analyze what's happening in the build and have full access to that data. One of our modules is called Dead Smart Data, where we're collecting all of the information happening during the build inside of the machine speeds and feeds, as well as all the build-specific information such as laser power, melt pool size, temperature, layer thickness. We combine all of that data and put it into a very user-friendly PDF build report at the end of each build. That build report, in addition to all of the raw data that's time-stamped coming off of the machine, is accessible by our end users to help really understand the quality of the build and help if they need to go through a qualification process. We also offer a piece of software called Dead Smart Visualize, which is a tool that after a build, a user can ingest a single or multiple builds and dig in a level deeper into what's happening in the build, be able to compare from one build to the next for repeatability, and to look at all the different variables in the system and plot them out to really understand what's happening and make any tweaks that might be necessary for future builds.
Our Dead Smart control system provides best-in-class melt pool monitoring, closed-loop control, and data logging capabilities for voxel by voxel analysis and qualification. FormAlloy systems are the only machines that enable printing and processing with both metal powder and wire feedstocks. Additionally, our Dead Smart control system provides the backbone of our product line. Most customers investigating FormAlloy systems are looking to reduce reliance on foreign suppliers, reduce lead times for castings and forgings, and provide a toolless, moldless solution to their manufacturing needs.
Turbine blade manufacturing and repair is one use case that is very beneficial to adopt this technology for. And that is due to all of the automation that we have inside the FormAlloy systems. So we are able to take a turbine blade, scan that turbine blade, and then automatically deposit the material just where it's needed. Now that material may be a rebuild up because of a worn or a damaged blade, or it may be to add a higher performing material to increase the life or wear resistance or hardness of the turbine blade just where it's needed. FormAlloy technology is trusted by aerospace and defense customers, Tier 1 suppliers to the Department of War, the US Navy, and consumer good companies like Milwaukee Tool. They utilize FormAlloy because they are able to get insight into what has happened during their builds and really prove that the parts are high quality and can be used for their demanding and high throughput applications.